Okay, hi. This is a question. Tom enters a tennis competition where he plays three matches every day. The results of each match are independent of each other. Okay, let A be the number of matches Tom wins on any given day. So A is our variable. Our variable is A, and as we see, A can only take integer values. Tom can win one match, two matches, zero matches. Tom cannot possibly win zero point 0.1 match or 2.1 matches. So it's a discrete variable, discrete random variable. The probability distribution is given in this table. Okay, so find the value of P. Now we know that Tom is playing three matches, and these are the only four possibilities. He can win, he might win zero matches. He might win one match, two matches, or three matches. These are the only four possibilities. There is no fifth possibility. So, the sum of all these probabilities should be equal to 1. Sigma p should be equal to 1. Therefore, 0.15 plus 0.2 plus p plus 0.25 is equal to 1. Now when we solve this, what do we get? We get 0.15 plus 0.2, 0.35 plus p plus 0.6. So we get p plus 0.6 equal to 1. So p equal to 1 minus 0.6 equal to 0.4. So my p is 0.4. P is equal to 0.4. I will write here 0.4. Okay, now a day is chosen at random. We go to part B now. A day is chosen at random. Write down the probability that Tom wins every match he plays. There are three matches. Tom wins every match, okay, which means he wins all the three matches. And from the table, we know that the probability that Tom wins all the three matches is 0.25. So my answer is 0.25. Now, there is a hint here. The command term used is write down. The command term used is write down. Now, write down is an IBDP command term. It means you only have to write the answer. There is no need to show any working, any calculation, nothing. You don't have to show anything, just the final answer. And the final answer, which is usually easily obtainable from a data that has been given before, from information that has been given before. So here we know that the probability that he wins all the three matches is 0.25, right? So that's the answer to question B, part 1. Now question B, part 2. The competition goes for 4 days. Now find the probability that Tom wins every match on exactly 3 of these days. Correct? So the competition goes on for 4 days. And you want that Tom should win the match on exactly 3 out of these 4 days. So let us say, okay, let me write it here. Okay, I'll write it here. Let let n, or I'll say x, I won't say n. N we normally use for sample size. So let x denote the number of days let x be the number of days that Tom wins every match, which means three matches. Correct. Let x be the number of days that Tom wins every match. Yeah. Now x is binomially distributed. Number of trials for. See, each day is a trial. Day one is a trial. Day two is a trial. Day three, day four. There are four trials. Now Tom may win on day one or not win. Tom may win on day two or he may not win. Again, day three, day four. So Tom can win on any number of these days. Tom can win on 0 days. Tom can win on 1 day, 2 days, 3 days, or 4 days. So X is binomially distributed. 4 is the number of trials, and the probability that Tom wins every match is 0.25. Okay. So now we want to find the probability that x x equal to 3. Right? He wins 3 matches. He wins on 3 days. Okay, exactly 3 days. So now we will use our GDC, and we will use the BPD function of GDC. BPD function. Okay. So what we will do is, let me just open my GDC. Distribution, binomial, BPD. Okay. We will say x is 4. Sorry, x is 3. Number of trials is 4. Probability of success is 0.25. So we get probability. So we get probability x equal to 3 is 0.046875. All right. Sorry. Yeah. Okay. Which is, this is my raw answer, which is equal to 0.0469 to 3 significant figures. Okay. So that's my answer. The probability that Tom wins on exactly 3 days is 0.0469. 0.0469. Okay. Okay, this question I think we'll solve in the next video.